Hi guys, I'm Sajjad Rezvani. I'd like to talk about polynomial regression in this session. First of all, I'd like to introduce myself quickly. I'm 24 years old. I recently finished a bachelor degree in electrical engineering in Shahid University. I have programming from 3 years ago in T&M company, and I learned programming when I was high school about 10 years ago exactly. First of all, I learned C++, then I continue and learn other languages, and now I'm most of the time programming in Python. And in university, I have learned several courses such as machine learning, signal processing, math, and physics. So let's move on and share a screen to talk about polynomial regression. So in this tutorial, we like to know about polynomial regression. When we have these type of data, that as you see, there is no straight line relation between y and x. If you use actually a straight line to model these data, you can't get a good error. To better understand this, I'd like to show you this plot. We have these points, which are our data. In the left plot, we have a simple linear model with equation that is y equal to b0 plus b1x. In this equation, we have a straight line, but as our points have a complex pattern, you can't have a good error in this modeling. As you see, the points are too far to the line. But in the right plot, when we use a more complex model, which is a polynomial model with equation such as y equal to b0 plus b1x1 plus b2x1 square, you have a curve which is better fitted to our points. In this way, we have a better model. So that's why we use a polynomial model instead of simple linear model in these type of data. So let's back to the tutorial. In this way, we use the powers of the x instead of just an x. As you see here, we have x1 in power of 1 and in power of 2, actually in power of 0 in this element, and we could have several powers of the x in this equation. So let's move on to the code to better understand the concept. In this function, we want to build this matrix which concatenates the powers of the x in a same matrix. First of all, in these two lines, actually we should comment this line. First of all, in these two lines, we convert or broadcast the shape to n to 1 to properly concatenate the x. Then we build a design matrix with np1s to gather all of the powers of the x in this matrix. And then using this for we actually build the powers, which is degree, from 1 to the order, which is the biggest power. And here we could use np.h stack. And here we should stack the design matrix and x, which is the or variable or input in this function. Design matrix have some issue in type here. I think it's okay. Yes. Then we return design matrix, and here we could run the function here. As you see, it's okay, and we have a good result, the same as the answer of this cell. And to better understand the mp.h stack, I like to show you this picture, which shows that we have a first and second matrix using nph stack. We concatenate them together, which is a horizontally stack actually. And just this. Thank you very much.